promise, right? We're going to look at. We're going to try to replace all these low-level events and instead substitute them or translate them into some higher-level representation that is more specific to our particular application, and the code that goes along with it. So the prior implementation that we have so far we're specifically working with these very generic low-level events, right? Every single keystroke, every single mouse click, and whatnot. We're going to replace this. We're going to wrap them into either lambdas or objects that encapsulate these low-level events, right? And also make use of the design pattern we introduced earlier, the command design pattern, right? We'll wrap these low-level events into high-level actions, okay? So that it'll make it easy to extend the controller if ever we want to make it even more generic. And we'll also make use of a Runnable class that you can embed algorithms inside of these runnable classes, these runnable objects, and then invoke them at a later time. Right? You can configure and embed all sorts of low-level stuff that you don't really care about, right? And then just execute them, postpone their execution at some later time, which is basically what the command pattern is, right? We're going to have all these lambdas or objects that we can then run off of a hash map, okay, or a map. So we're gonna keep track of 3 maps, okay. 2 maps are going to be used for representing any number of key presses or key releases. In our case, we only care about pressing one particular character, right, and then releasing that particular character so that we can toggle the capitalization. Yes. So we'll put all our runnables in there that handle those 2 types of events, and then we'll have another map that keeps track of. I'm sorry, 3 that map the keys, the key press, the key releases, and the character that we typed. Okay, and we're just gonna populate these maps just like we did earlier for the command pattern that we implemented. Was it? I think it was early this week, right? We did the command pattern, or was it last week? I forget. So following that same strategy, right, and we're going to rip out that ugly switch statement in the controller, and instead run it through, run these events as the events come in. We're going to use the token or the command off of the event that comes in to look as a lookup into our table, into our map, right? And they'll say, oh, it's this. This is the command, right? I don't need a switch. I can find it immediately, and then once I have that command, I can just say run, right? Execute yourself, right? Execute it. Oh, I'm sorry. English is not my first language. Right. So what we're going to do is that the controller is still going to be a listener, right? It's still going to listen for these events that are being generated by the view, and we're going to do we're going to have a map that presumably that map has the command that needs to run. And we're going to use the character as a lookup. It says, I'm going to use the C or the capital C or whatever token we want to use as a lookup onto that map to retrieve what action you have stored in that map. Okay. In this case, we're going to look for a particular character key, whether it's T or D or capital C or whatever it is. Right? We're going to use that as a lookup into our map, and it says, okay, well, is it in there? Is this keystroke that you typed? Is it in the map? If it is, go fetch it. Retrieve it for me, and whatever is stored in there, presumably it's some executable, right? That can be run at some later time, and indeed we run it. Right? This immediately removes the need for even a switch, right? Because the switch was looked at the different characters and whatnot, and then it ran and executed a particular command. Instead, here it's immediate lookup on that, right? We would do the same thing for key type, for key up, key down, right? They would look up into different maps, right? You would have different maps for different. And also, we only have one command, right? Of capitalizing or uncapitalizing and changing the color. We only have those three keystrokes, right? But we could have any number of them, represented in these maps, right? Like if you had all sorts of shortcuts, right? In an application that you do shift this, shift that, control that, all mapped off of this, right? And to just implement a new feature would be just as easy as populating these maps, for new features, for new toolbars. Then these dictionaries would contain the executables, would run, and we do have to populate these maps, right? These maps would have internally some either lambdas or some runnable objects that we can then run. So let's take a look at some examples. Here's as part of the controller, right? Once it instantiates itself, we can ask itself to configure itself, right? So instantiate these maps, fill them in with all the lambdas, all the objects that are runnable, right? So we initialize these, hash map for the characters, integers, and then we can populate it, right? We can map. If the event is the character C or the character T or the character D, right? We would then instantiate these command patterns, right? These are the command patterns these are executable objects that internally have the algorithm of what it is that you want to happen, right? When you execute these things, right? This is identical what we did, a couple of lectures ago, right? That we embedded. I think we called it Go in that time or something like that. We called it differently. And we can also pass along with these objects, if it needs to modify the model, right? We could pass the model here, right? Because the controller has access to the model. It has an instance to the model. We can pass it along. Yes.
Is Runnable something that we made, or is it part of Java?
No, it's part of Java. Yeah, it's out of the box. What we did is we implemented our own interface. Here we're using an interface that already exists, right? The runnable interface. It just declares a run method on it, so you can run it, execute whatever's in there at a later time. So you would populate for every keystroke, whatever you would need. Here's another one, for instance. This one has an actual object that we can instantiate. Yes, if that object needs to maintain some state, or we need to pass in some parameters so that we can configure the behavior. This is a great option, right? You have an actual class that you can instantiate. Some of them are too trivial to even have a class, right? Maybe you don't even need a class. Right? So why even bother if it's something as trivial, maybe as quitting? Do I even need a class for that, for quitting, right, the application? Maybe not, right? So I might go a little bit more terse and say, well, I'm not going to create a class for this. I'm just going to instantiate a runnable, and internally I'm going to have the run method, and whatever I put in there will execute at some point. Yes. The run method will be invoked, right? And internally, I can modify the model. Notice that this model, because I'm being instantiated, all this is happening inside of the controller. The model is still within scope, right? When we instantiated the model early on into the control, we passed the model to the control. The control has an instance, a reference to the model. So this runnable anonymous class, right, anonymous object, right, and we never assigned it to anybody, right? has access to that model, so that it can manipulate it, right? It not only has access to the model, it also has access to the view, so it can talk to both, right? That's what the controller does, right? The controller can talk to the model and talk to the view. What is it doing? It says, "Give me the original string, and then I'll modify it into an upper and then set the view." Notice that it never mutates the model. Right? It doesn't need to mutate the model. Right? The model always has the correct case, right? The correct string, because we only, the way we implemented it was that it was a temporary capitalization, right? When we pressed the character C, right, and we held it down, maybe when we typed it, okay, and then we would capitalize, and then when we released it, we went back to the original case. Right? So we're handling both separately. Right? So there's no need to modify the model and change its case. Right? It's only for representation purposes for the user. Very very much like when you zoom in on Photoshop or whatever. Right? The model has the entire picture, the entire image, but for convenience, we provide transformations such as zooming in, right, and zooming out. Yes, you're not actually modifying the model. The model is always the same image, right? But for convenience purposes, right, we allow transformations on that data, right, only for our convenience. So we represent the instead of just pixel to pixel, we zoom in and say, well, actually 1 pixel now becomes 4, and then becomes 8, and then becomes 16, right? Only for our purposes of being able to zoom in or zoom out. But the model itself never changes. Make sense? So that's a point here, right? That the transformation is happening only for human consumption, right? But never because we're actually modifying the internal representation. Once we right, so there were several ways that we're implementing that, right? A whole class that it's implemented the Runnable interface. Another one here, an anonymous instance that we're instantiating right away, but still an object. We're still an object. And the third implementation is the other way to implement it is through a lambda. Using the lambda that's now available in Java 8. It's a function. It's not even an object, right? That we still have access to the view. We still have access to the model, right? Now internally, obviously, this is a syntactic sugar, right, for Java. Internally, it does instantiate an object, right? And it calls that function declared in that object. Yes, but this is a syntactic sugar that allows us to work with anonymous functions, which is pretty cool. So that function will be invoked at some later moment when R is identified as the token out of that map, right? And then that lambda will execute. We'll still have to notify the view that we are listening for all the keystrokes, right? And that we're gonna look up. Based on those characters, we'll look up the map and execute either the objects, the lambdas, right, or the anonymous objects, right? Make sense? Right. So we were able to generalize a little further, right? Kind of hiding these details and applying the command pattern. That we introduced a couple of days ago, and this makes our controller much easier to enhance, to add features, right? So that you only have to modify this map.